Hi everyone, so in this video I'm going to do a quick review of the Operon, and then I'm also going to go through some of the mutations and how that affects the levels of transcription in the wild type versus in the mutant. So the Operon consists of this like MAL-P and MAL-Q, the MAL-P and the MAL-Q genes, and then also this MAL-T, which in difference to the lac operon, MAL-T is now an activator protein. And the way that this activator protein works is that when maltose is present, it can bind to the activator and basically activate it through a shape change. So MAL-T is in the wrong shape to bind to the operator when it's first produced. So when maltose is in the cell, it can bind to MAL-T and basically make it a shape change so that it's now able to bind to the operator. So once we have like the maltose or the MAL-T form with maltose bound, it can bind the operator, and what it does is it basically turns promoter 2 into a stronger promoter so that RNA polymerase can be recruited more easily because now this promoter is stronger. So hopefully that gives like an idea of what's going on. So in the presence of maltose, the activator is in the right form, and so we're going to be able to transcribe MAL-P and MAL-Q. And okay, so hopefully that gives an idea of what's going on, and MAL-P and MAL-Q are needed for the breakdown of maltose. So now I'm going to go through some of the mutations that we talked about in class and sort of explain the reasoning for how we went through those. So the first one I'm going to do is I'm going to basically remove the operator. So there's some sort of sequence change that makes the operator like ineffective, it's inactive. Maltose or MAL-T will not bind to it like no matter what. So our mutation is operator not functional. And I'm going to do this in the presence of maltose. Okay, so we ask ourselves, what happens in the wild type when maltose is present? Okay, so we have maltose, and it binds to MAL-T, which is now activated, so it can bind to the operator, which then leads to an increase in transcription because we're turning P2 into a stronger promoter. So we're making more MAL-P and more MAL-Q. Great. Now in the mutant, so maltose is present and it's binding to MAL-T. Great. So MAL-T is active, but no operator. So MAL-T cannot bind the operator no matter what, because even if maltose is present and it binds to MAL-T, MAL-T is in the right form, it's ready to bind, but the operator site is not available because it's not functional. So we'll see a decreased level of transcription because P2 is the weak promoter that we're used to seeing. There's no enhancement of the promoter strength. So there's no increase in transcription. So we would say that the mutant has a decreased transcription of MAL-P and MAL-Q compared to the wild type. Great, okay. So now the next mutation. Okay, so in the next mutation, we're going to remove this entire section. Not remove it, but like whatever, make it dysfunctional. So as if it didn't have the functions that it had before. So we remove T1 and the operator. Okay, and this is going to be in the presence of maltose. So in the wild type, again, we have maltose. It binds to MAL-T. Now this is active, so it can bind the operator. So we increase the transcription because we've increased the strength of promoter 2, so RNA polymerase is binding more often. So it's transcribing MAL-P and MAL-Q more often, so we're making more MAL-P and MAL-Q. So now in the mutant, so we've removed T1, So we have maltose. So we've removed T1. So now we still have promoter 1 and we still have a terminator, right? And we have to remember that RNA polymerase, this is RNA, it binds a promoter and it goes to a terminator. So no matter what, it sees this promoter, it binds, and it'll just go all the way to T2, right? And then maybe like an RNA polymerase will also bind to promoter 2, and it would go all the way to terminator 2. Okay, so great. So we know that we're transcribing MALT, and we know that we would then translate it because we still have a promoter and a terminator. It's just not the usual terminator we're used to, but it's okay because we still have promoter and terminator, and MALT is between those two. So we're definitely going to transcribe it. It's going to be in our mRNA, so it can then be translated later on. Okay, so maltose will bind MALT, and it'll activate it. Great, but now we don't have an operator. Again, just like before, no operator. So this whole step doesn't happen because even though MALT is active, there's nowhere for it to bind. So it's as if it's just useless. It was made for nothing. But now we have to think about what's actually happening. So we're transcribing the usual P2, right? It's the weak promoter. It's transcribing MALP and MALQ. So it's not great transcription levels. But we also have this like second transcription that's occurring. So we have promoter 1 to T2, right? This arrow that I drew up here, that's also transcribing MALP and MALQ. So we're transcribing from P2 to T2, but also P1 to T2. So sort of like if you have one RNA polymerase binding here and then another binding here at the same moment, you're actually making two transcripts of MALP and MALQ in the same sort of time step. So you would actually see an increased level of MALP and MALQ to what you would see in the previous mutation where you just have a transcription because RNA polymerase is binding to the weak P2. But in this case, you're actually copying it like a second time because now you have P1 to T2 also being transcribed. So we would see like a little more transcription than basal, but it's nowhere near the level of transcription that we had up here because P2, like when MALT is active and it binds to the operator, it enhances the strength of P2 so much that like it's such a strong promoter now that RNA polymerase is binding so frequently. So even though we have this like second pathway from P1 to T2, so we're transcribing MALP and MALQ more, it's still not as much. So we would say that we have less transcription of MALP and MALQ in the mutant as compared to the wild type. Okay, so hopefully that was clear. And now I'm going to go through, I think one last one. Okay, great. So in this last one, I'm going to remove the terminator. So terminator 1, the terminator that's associated with MALT. Okay, so this is one that's a little bit trickier, but we're going to go at it the same way. So I've removed T1, or it's not functional. And we're still in the presence of maltose. Okay, so in the wild type, again, we have maltose binds MALT, which binds the operator because it's now an active form and it increases the strength of promoter 2, so we have increased transcription of, or just increased transcription, let's say that. Okay, of MALP MALQ. And then in the mutant, so, okay, now we have to ask ourselves what's happening here. So we still have maltose, that doesn't change. But now in this case, are we still making MALT? Well, again, yes, we are, because we have P1 to T2. So RNA polymerase can still read all of this. So we're still making mal-T even though T1 is not present. So still being made, we can still, have mal-T present and maltose can bind to it. So we have mal-T present, maltose can bind to it, and we will have binding of this active mal-T to our operator. Okay, great. So we have binding to the operator just like we did in the wild type, right? That's what we said. But now we also have this other situation, or sort of like an addition, another level to this, where we also have transcription of mal-P and mal-Q from the second sort of pathway that we mentioned before by transcribing from P1 to T2. So not only are we transcribing from P2 to T2 with now a much stronger promoter, right? This is now, oh my goodness, this is now stronger because mal-T is binding to our operator, but then we also have this additional level of transcription that's coming from RNA polymerase binding to P1 and then going all the way to T2. So this is where we could say that we have an increased transcription from like P2 to T2, but we also have transcription from P1 to T2. So it's really like how much more is this second part, right? If it's quite a bit more, then yeah, we would say that the mutant is making more of mal-P and mal-Q transcript as opposed to the wild type. But if we say that P1 is a really weak promoter, then it's sort of negligible. So that means that it's not really that much more, because P2 is just so strong that really anything made from P1 to T2 is not really that much more, so it's not significant. So in this case, I think in class we said that the answer would be more because we've had this additional transcription, but I think they would also accept the roughly equal answer because it really depends on how strong P1 is in comparison, or how weak P1 is in comparison to P2. So on an exam, you would be provided with more information, and they wouldn't be this tricky on you. So hopefully that helped sort of clear up some things, and also explain a little bit more how the reasoning happened for all these mutation questions that we did in class.